All right, guys, welcome to the 4.3 notes on rotations and all things rotational. Essential question, how can you rotate a figure in the coordinate plane? Let's do it. Our friendly neighborhood Geogebra website can help us with this one. All right, so our Geogebra calculator, sweet. Let's see what we got. All right, tools. Polygon. Where are you, Polygon? All right, so our exploration says draw a triangle. 3, 1, 5, 2, 4, 4. Wrap it back around to where you started. We got ourselves a nice little triangle. All right, now we have to put a point at the origin. In this section, in this chapter actually, all of our rotations are going to be counterclockwise around the origin. In the world of geometry, you can rotate around any point, but this book keeps it simple, keeps it at the origin. So put a point at the origin. And now, our section entitled Transform is where we find the reflections from section 4.2, the translations from 4.1, and now here we are, we're going to rotate. So now once you highlight the rotate feature, click the triangle and the point you want to rotate around. Then a box pops up. This exploration wants you to rotate this triangle 90 degrees around the origin. As you can see, counterclockwise is the default in Geogebra as well. So click OK, and you see what happens. This triangle was rotated 90 degrees counterclockwise around the origin. So the new coordinates, which you can find under your algebra heading as well, if you just scroll up, there's A prime, B prime, C prime. So let's take a look at what happened. A went from 3, 1 to negative 1, 3. Ooh. B went from 5, 2 to negative 2, 5. So you switch the numbers of x and y inside the coordinate, and you apply a negative to the x value. So that is a 90-degree rotation by hand. You would just use those rules. By Geogebra, you would just look at it here. So keep in mind what's happening here, friends. I go to my move feature. The triangle, if I place A on the x-axis, you can see that A prime then would be on the y-axis. It went 90 degrees. So no matter how close you get, A prime will get that close and stay 90 degrees apart. All right, so there you go, my friends. Where we started out right there. So that's our exploration. Let's head into the notes now. So when we perform rotations, it's just what we did right there. Rotation is indeed a transformation, in which the figure is turned about a fixed point, called the center of rotation. Right. Now, if you're going to do these by hand, like I said, there are general rules for 90. So whenever you have 90, 180, or 270 rotations, and the one we just analyzed was switch the numbers on x and y and make the new x value negative. Okay. So, example 1. Heading back to Geogebra, let's take a look here now at what we would do with this quadrilateral, and then we're going to rotate it 270 about the origin. And again, you could apply this rule by hand, switching the numbers, but let's practice Geogebra while we are here together. So 3, 1, 5, 1. I'm going to go clear all. Quadrilateral. So polygon. 3, 1, 5, 1, 5, negative 3. What was our last point? 2, negative 1. 2, negative 1. All right, and not quite on this point. Hang on a sec. There we go. All right, so 270 around the origin. So again, put a point at the origin. And now drop it like it's hot, all the way down to transform. Rotate around the point. Click the quadrilateral. Box pops up, 270. And there you go. So we've taken this figure and rotated it 270 degrees about the origin. So like, for instance, A is 3, 1. So A prime is 1, negative 3. Well, A prime, or R prime in this case, would be 1, negative 3. So you can see how you could apply this concept. You switch them, and then you negate the Y value. So it would work if you went through by hand. If not, you can just use Geogebra. All right, monitoring progress. Now let's take a look after a 90-degree rotation. So we've got, I'm just going to write this down real quick. 3, 0, 4, 3, 6, 0, 90-degree rotation. All right, so let's clear what we have. And polygons, polygons everywhere. So this triangle is 3, 0, 4, 3, 6, 0. All right, and we want to rotate it around the origin. So put a point at the origin, 90 degrees. So go back to transformers, rotate around the point. Click the triangle, click the origin, 90 degrees, and there we go. So on a quiz nizzle, we would be looking for A prime, B prime, C prime, those 3 points. Whoop, there it is. All right, rigid motion coming back into play again in isometry. When you move these things, when you rotate them, they do indeed stay the same size and shape. So a rotation is also a rigid motion. All right, now performing a composition. This is when we're going to do 2 things. So we are going to reflect and then rotate this segment. So it doesn't have to be a triangle or a quadrilateral. It could be just a simple old segment. So let's go back to Geogebra. Clear it out. Clear it out now, y'all. Now we want a segment this time. So segment should be under lines. So go down to the line setting, segment. And this segment is 1, negative 3, 2, negative 6. I can't see it yet. Hold on. Move my graph paper. I'll tell you what, move your graph paper down for this one. We're going to be in the 3rd and 4th quadrant. So then I was at 2, negative 6. So 1, negative 3, 2, negative 6. First thing I'm doing with this is reflecting it in the y-axis. So now what's cool is if you're reflecting in an axis, you don't have to put the line on. Typically we would be like, all right, let's draw the line that we're going to reflect around. But since it's an axis, you don't need to put the line there. You can just use the axis when you click on it. So come all the way down to transform, reflect about a line like we did in section 4.2. Click on the segment and the y-axis, and there's the first step in our composition. Next, we want to rotate it 90 degrees about the origin. All right, so I need to point at the origin, point, origin, Come back down to transformers. Rotate around a point. Now click on the segment and then click on the origin and the box pops up. Tell it 90 degrees. Hit OK. And so now this new image was rotated 90 degrees to create a double new image, A double prime, B double prime. So the coordinates here, 3, -1, and 6, -2 would be your answer on the quiz. So that's a composition. All right, so try this one. Take the triangle and do those two things to it. Pause the video and pick it back up when you're done. All right, so let's see how we did. Let's clear this out. All right, so now we want to grab the triangle. One, 2, 3, 5, and 6, 3. Just make sure I have my points right. 1, 2, 3, 5, 6, 3. And then we want to rotate this around a point. So of course we have to put a point at the origin. And then we can rotate it. So just go in order what they tell you. The first one here was a rotation. So rotate this triangle around this point 180 degrees. So you can see all the x's like 1, 2 became -1, -2, etc. And then from there we want to reflect it in the x-axis. So reflect the bottom line. The new image was here. So click on it, reflect in the x-axis, and there we go. So A double prime, B double prime, C double prime. These would be your answers on the quiz. All right, and finally today, let's talk about rotational symmetry. We had reflectional symmetry yesterday, just a line of symmetry. When you reflect something, does it look exactly the same when you flip it over a line? If so, it has lines of symmetry. Rotational symmetry is when you spin it. Does it look the same when you spin it, ever? And we say between 0 and 180, so 180 degrees or less. And let's see what we got here. So for example, in this particular fan-looking thing, it starts out here. It spins 45. No, it looks different. Oh, but when it spins 90 degrees, it's the same as when it started. When it spins 180, it's the same as when it started. So it has two different rotational symmetries, 90 and 180. Each of these degrees will map the figure onto itself. Now, point symmetry is the phrase we use whenever you have 180 degree rotational symmetry. So if you spin something 180 and it looks exactly the same as when it started, it has point symmetry. All right, so let's take a look at a couple of these examples here. And let me try to make things a little easier for you. Let's start out here. All right, so we got a parallelogram. When I spin it, nope, different, 90. But when I go 180, it looks exactly the same. So we would say yes to this 180 degrees. So that's point symmetry, a specific type of rotational symmetry. The octagon, let me get you an octagon here. All right. How does it start out like that? Okay, so when I spin this octagon, no. Oh, But when it's spun 45 degrees, when it's spun 90 degrees, 135, 180. So it has a bunch of different, so if it's regular like this, it's going to have a lot of different rotational symmetries. Anytime you can get it back to where you start. So for this one, we would say yes at 45, 90, 135, and 180. It looks exactly the same as when it started. Now, unfortunately, this trapezoid is not going to have any rotational symmetry. Try to help you out here with this little visual representation. All right, so start out like this. Spin it 90, spin it 180. It doesn't look exactly the same until it gets all the way back around to 360, and that doesn't count because every figure would have that. So we would say nope for the trapezoid. All right, you can pause the video one last time, see what you come up with the monitoring progress. And we're back. The rhombus, oh yeah, just like the p-gram, up above 180. Ooh, this octagon, when it goes 90 or 180, so it's going to be a yes, 90 or 180. And unfortunately, the right triangle, nothing would work here. So no. How about no? All right, friends, so that's 4-3. Peace.